morning. My name is Madeline Holzer. I am the Education Event Specialist here at Zahn, and I'd like to welcome you to this morning's Quick Bite, Make Your Design Count with Milos Markovic, CDT. He's the Director of CAD/CAM and Implantology at Aurora. And I just wanted to remind everyone, in case you did have questions during the session, please utilize the Questions tab, and we will be happy to address them as time allows towards the end of our session. Welcome, Milos.
Thank you for having me again, and thank you all for joining us today. Today is more of a sort of like a refresher to go over some of the design preferences, some of the design tricks when you design your bridges. The idea is to save you time, to kind of give you a little pointer as to what to focus on when you do your designs, and kind of what to look out for when you deal with digital files. So hopefully today will be a refresher for those of you who are familiar with it, and maybe for those who are not, to learn something new to maybe try to implement into your workflow. So again, proper bridge design, it's something that we find that a lot of designers happen to neglect, especially when it comes to force distribution and the connectors in your design. This will help you reduce your milling problems. And then we're going to kind of switch over focus to common issues designers face today, what to look out for digital files. So pretty quick rundown on some of these things. So why does it matter? Nobody likes a remake. There were too many situations where the designer would just sit there, spend a ton of time designing something that's maybe incorrectly designed or didn't have enough information, goes into production, turns out it's wrong, you got to go back, or it gets produced, goes in the patient's mouth, fractures after a certain amount of time. So that's all saving you time and money if you do it correctly, but also costing you time and money if you don't. So that's the whole point of today. I wanted to give you a little view here of, are you placing bridge connectors? So bridge connectors in this instance in 3Shape design software allow you to create sort of like a uniform or a definitive shape for your connectors. A lot of times what designers tend to do is to just take the two units, two crowns, and kind of fuse them together and then let them be. And then they do their STL design output, and it goes into production. The benefit of doing connector design is that in 3Shape, you can actually calculate the area, the surface area that your connector has. So this is sort of like a quick check to make sure that your connector has enough thickness. And so if you kind of bypass this step and go to the final step, your bridge might fracture because it doesn't have sufficient thickness. It's hard to gauge whether or not your bridge has sufficient thickness without a connector just by looking at two crowns, because everything in the design software is zoomed in. So you don't really have a reference to how big your tooth is unless you start measuring it. So what you should do is you should choose a silhouette connector. That one kind of starts with like the most broad surface and kind of try to like spread it around your contact area. And we're going to go over why that really matters. So it increases restoration strength, it decreases the cam strategy calculation, and reduces potential milling problems of small burrs and small tools trying to reach area that are just unreachable simply because of the limitations with the tool diameter. So common design, right? In a common design, you're going to see we here have a red outline to kind of accentuate how the interproximal connectors work. In a common design, the designer is just going to take two crowns and fuse them together. So if you think about how milling works, if we take the milling burr, which is represented by the blue circle here, the milling burr is just going to try to go back and forth and never really be able to mill out that area simply because it has a limitation. The software is just going to bypass it. So it's going to do the same thing on the lingual as well. It's just not going to be able to reach that area. Also, where you see the blue arrows, they accentuate that small triangle, that unreachable area. Now, when you do your CAM strategy calculation, the software is going to try to calculate to reach that area. So by exposing that area and making it available for calculation, you're actually increasing your calculation time, especially becomes more noticeable when you have a large bridge. So if you multiply that by 14 teeth, and all the interproximal connection, buccal and lingual, and you multiply that and put it together, you actually add in calculation time. We were able to measure that it shortens calculation time if we have a better connector designed. Here we have an example of a connector that's a little wider and it's a little more rounded. And so what happens is the burr is actually able to float easily back and forth without having to reach that particular area. And it's exactly the same thing on the lingual as well. And so that really helps with overall design. And here I want to give you an example of what really happens in milling. So as the milling strategy gets calculated, it gives us, potential problems. This is an undercut area. This area is too thin. So when you leave a thin interproximal connectors, or those really sharp interproximal connector designs without the connector, you're going to see that on the left and on the right side here, you're going to see that smallest burr trying to reach that area. And so that creates potential problems because burr is trying to get in there. It's also trying to reach an undercut area multiple times. Here you see the mill like kind of twisting in all 5 axes just to be able to reach that area. And so that creates a problem. And we've seen fractures in instances where we have an extremely wide height of contour and the small burr trying to reach that interproximal area. So flexing muscle, right? We want to use that. So why is this important if you do create a proper connector in your bridge design? Well, here we have an anterior bridge with really nice wide connectors on the lingual. And we want to show you when those connectors are wide and rounded, the force distribution when that bridge takes on during your mastication, during your chewing, is it just kind of flexes, just like a regular arch bridge, right? So the force keeps bouncing from one side to the other. And if you have a nice rounded feature, like you see here, the force gets to travel freely from one side to the other. Now, if you leave a thin, sharp point, in this instance, when that force gets exerted onto the bridge and that flexing starts to happen, if you have a sharp point, all the forces get focused on that particular point. And that's what we usually see with anterior bridges. They usually break between the centrals or between the central and lateral because those connectors are not properly designed. And that's the part of your mouth that during your chewing, when your lower interiors exert a tremendous amount of force. So to put that in perspective of a bridge is a bridge is a bridge. That's what we like to say, right? Because it doesn't matter if it's a bridge in the mouth or it's a bridge out there that's, Brooklyn Bridge or Manhattan Bridge. The same physics apply to it. So if you look at the typical arch bridge design, you're going to see how the bottom is rounded. And so when the force gets exerted onto it, the force keeps bouncing back and forth, and it's able to freely travel throughout the bridge. If you did not have that arch underneath, you just had like a straight square, that bridge would not last very long and you would have a lot of problems. And the engineer would probably lose his job. So that's basically the same concept, and you should try to implement when you do your bridge designs. It also becomes important depending on the type of material that you use. On PMMA restorations, we actually tend to make that lingual connector even wider because we really need that provisional to last. If it's a surgical provisional, after the surgery, we need it to last a good 6 months. Up to 6 months. So we really try to thicken, almost create like a tissue design on the lingual, kind of connecting the entire lingual side, and then maybe individualize some on the labial side. And we really found that milling PMMA restorations with let's call it excessive lingual connector design really helps with that durability, and we see a lot less fractures that way. So that's basically going over the bridge, right? So we went over a couple of things. We know why it matters to design a good bridge, design a good connector. It helps with force distribution, strength, helps with milling. So overall, it's a good thing to implement during your designs. Now let's shift a little bit. Let's talk about good ideas to avoid remakes. So as somebody who works in the digital field for quite a while, we see a lot of strange scans, if we can call them that come in. And over time, we've learned kind of what works and what doesn't and what to look out for. So our file retrieval department is probably the most interesting department because that's where all the files come in from multiple customers, and you really need to pre-filter what's coming in and assess what's good and what's not, and maybe send it back if it needs a new scan or readjustment. So validating your dentist's intraoral scans as soon as possible, and then maybe even while the patient is there. So this is, once we mentioned that Henry Schein's design services, how they have a scan validation tool that actually allows for you as a lab and as a dentist to validate the quality of those scans while the patient is there. During COVID times now, rescheduling has become a big problem. Dentists don't see as many patients. And so we do cases, we're now maybe getting some cases inserted that we did back in November because the patients just weren't able to be scheduled. So having the ability to assess the quality of that scan so you don't have to reschedule patient for another one is important. And if you have the ability to either do it yourself as a lab, to quickly jump on TeamViewer or any other remote service onto your dentist Trios or iTero, whatever they use, and to quickly see how that scan looks, or just have them send it to you and quickly take a look while the patient is still there, they will save you and the dentist a lot of time and money. And we find that doing that really helps. So whenever we receive our stuff, we try to jump on it right away, and it helps. Next one is marginal clearance, whether you pack in the cord or not, right? A lot of intraoral scans now are coming in without the cord packed, and we have to do a lot of trickery to decipher where the margin is. So we're going to go over a little bit about what that means and how that looks, and then what to look out in occlusal alignment scans when you receive them, how to recognize what's acceptable in terms of misalignment, and how to compensate for some of that misalignment. And do you have a POI data to help you distinguish tissue from tooth structure? POI data refers to the color data that a lot of scanners output now. It's sort of like becoming a standard. It's a uniform format. And so we're going to talk a little bit about whether or not you should search for that data, how it can help you. And are there too many artifacts present? That one is interesting because we're going to show you some of the examples of cases where they're very interesting. Let's put it that way. So to cord or not to cord? That is the question, right? So we have an example here of a very good prep where the dentist had packed the cord. And so we're really happy when we receive those cases. The benefit is that the margin is very easily distinguishable. And we also receive a POI data, which you see on the side. Now, POI data also helps you distinguish between the tissue, which tends to be pink, or a little blanched, a little on the white side, and then a tooth structure, which is dentin. And so sometimes when the dentist even packs a cord that's blue, that's even more helpful. In this case, the cord is white, but if they pack the cord that's blue, that can even help you even more if you have the POI color data to distinguish where the margin is, because it kind of like packs itself underneath right under the margin. And so here, if you see on a 2D cross section, in this example of good cord packing, you're going to see right here that we have a very distinguished height of contour of a chamfer knife edge kind of prep, and this helps us a lot. So if you could work with your dentist, I know it's hard to convince them to change their ways, but really the tools have changed because now they have an intraoral scanner, but the process really should be the same, and having that clear margin reduces your remakes and reduces their chair time as well. So maybe during these times where they're not seeing as many patients and remakes are costly for them quite a bit, maybe they'd be willing to have that conversation again with you to see how they can improve their intraoral scans. So that's one of the main ways that we see that they can be improved. And then this is an example where the dentist did not pack any cord. And so it's interesting, it's difficult. So it's very hard to distinguish between tooth structure and tissue. This is also an example where we don't have a POI data. Some systems do not export POI data when you transfer them from, let's say, a Zirconia to a 3-shape. And so the color data gets lost. So you really have no good guidance for marking that margin. And so what you look for is little markers, shadows, you can move them around. But basically, to accentuate this image here on a 2D cross section, this is the area that's the biggest problem. It's mostly flat and smooth. And so we don't really know where that margin could be. And there's potential spots where the margin could be. So it could be up there, down there, a little further out, a little further in. So it really becomes a challenge to figure out where their margin is. And that's one of the main challenges that we have, especially when we pick up a lab that work with a lab that receives a lot of intraoral scans from some of these other scanners where and in situations where the dentist didn't pack the cord, and so it's kind of difficult to distinguish that. But we do our best, and we try to work with the dentist as much as we can and the labs to alleviate that. And here we have an example for occlusal alignment. So measure twice, cut once, right? So when you receive the scan, it's always a good idea to draw a 2D cross section and drag it straight across your scan, just to see how much are the maxillary and mandibular scans penetrating each other. And so in this case, we have a penetration of 0.222 millimeters. It's not the worst, but it's definitely significant to throw off your occlusal alignment and your settings. So if you already use preset settings to, let's say, make your design 0 into occlusion, this is actually going to make your design out of occlusion, because by the time that jaw really closes, your crown is already out. And so what we do when we don't have a recourse to rescan and realign this, what we do is we measure that distance and then incorporate it into our design, so that in 3Shape software, when you adjust your occlusion, if let's say we usually do our occlusion at 0, but now we know that the bites are penetrating 0.2, we're actually going to make our design negative 0.2, and that will compensate for when the bite actually closes in the patient mouth, it's going to end up where it's supposed to be. So it adds a little bit more design time, because it's a on case-by-case basis, where the designer has to go and do that measurement and then apply it onto their design. But we find that that's probably the best way to handle something like this. And MeshMix before ModelBuilder. So we utilize MeshMixer a lot. The reason being is because a lot of design softwares out there are not quite up to par when it comes to 3D file manipulation. They're getting there with each iteration of the software. They're getting better. But we find that MeshMixer, which is a free software from Autodesk, allows you to do a lot of cool things. So it's a original tendency to just take the intraoral scan, throw it in the 3Shape, let's say 3Shape ModelBuilder, and start doing it. And then once you're in there, you get stuck. You get too many errors. You can trim your model correctly because there's too many things going on. The software doesn't know what to look for, and you end up spending 20 minutes designing one model, which really should be done in under 5 minutes. And so what we found is that saves us a lot of time after the file comes into our file retrieval. If it comes in like that with a lot of scatter, with a lot of files flying around, emerging back and forth, we throw it in a MeshMixer, we clean it up, and we clean it up to a point on the right that you see. And so now we smooth the borders out, and we can probably do another course on just how to use MeshMixer, but we clean it up before we throw it in the 3Shape ModelBuilder. And so after that, it literally takes us probably not even 5 minutes, probably like 3 minutes to run this file in the 3Shape ModelBuilder with a nice flat bottom on the maxillary and mandibular arch, and it gives us no errors whatsoever. But when we input this file on the left, there's probably 20-25 minutes worth of messing around in 3Shape ModelBuilder if it even goes through. So super important to pay attention to, and try to utilize MeshMixer as much as you can until the rest of the design software does really catch up and maybe have their own 3D editing tool. And so the point of today was to be smart, save time, and save money. So hopefully you were able to get some of these ideas that you can implement into your workflow, and see what you can do with them. Definitely implementing some of these ideas will definitely save you time. We try to implement them ourselves, and we've seen improvement. Even though in some instances it's not going to be a major improvement, it's enough to make a difference, to make your day a little bit easier. And so hopefully you'll be smart, save time, and save money. And so thank you for joining me today.